again I am moving to the some important derivations as we discussed earlier from the unit 1 from the electrostatic field. We will also get some important derivations of the electromagnetic theory for the time varying field. Now in my today's session I will discuss about these derivations for the time varying field. Myself Dr. Sayanti Chatterjee, the Associate Professor of the Electrical and Electronics Engineering Department, IARE. So first we will discuss about the electromagnetic wave equation in the free space. For the free space, already we have discussed my earlier slide that the current density J equals to 0. What is the volume charge distribution? The volume charge, if the current density is 0, so the volume charge is always 0. So because current always flows in the conductor, so in the free space it is 0. Volume charge distribution rho is equal to 0. The permittivity of the medium of the free space is always epsilon is equal to epsilon naught, and permeability is equal to mu naught. So if we think about the Maxwell's equation, we know there are 4 Maxwell's equation. First is the modified Gauss law is equal to rho v by epsilon. Rho v is the volume charge density. Rho v is equal to volume charge density. As it is 0, so we got grad dot E is equal to 0. From the Maxwell's second equation, we already got grad dot B is equal to 0. Maxwell's third equations tells about the time varying electromagnetic field is equal to grad cross E is equal to del V by del T. And Maxwell's fourth equation, grad cross H is equal to J by del D by del T. Actually, grad cross H is equal to conductor current density plus displacement current density. As conductor current density is equal to 0, so that we will get the grad cross H is equal to del D by del T. Using this 4 equation, we will prove the electromagnetic wave equation in the free space. So first we got grad cross E is equal to del B by del T. Now we are taking the grad cross in the both side. Grad cross E is equal to minus grad cross del B by del T. So here we can write grad cross E minus grad cross E is equal to minus grad cross del B by del T. Or we can write it like this. Sorry, one small mistake. Grad dot E minus grad dot E. So we can calculate this equation like this, that grad cross A is equal to first one is fixed. Next the derivations of the 2 plus the second one is fixed, the derivations of 2. Now we know grad dot E is equal to 0. So we are getting here minus grad means grad square E is equal to minus grad cross del B by del T. We got grad cross is equal to grad cross del B by del T. Now what is the meaning of the grad cross del B by del T? From the Faraday's third equation, we know grad cross, we can write del B means mu into H by delta T. What is the B? I am taking this portion only, and minus cancel out. So we took this portion. B is equal to mu into H grad cross delta mu into H delta T. Or we can write it like this: mu is constant, grad cross H del by del T. We can also write mu constant del by del T grad cross H. What is the meaning of the grad cross H? Grad cross H is nothing but from the from the equation of the Maxwell's equation, we got that for the free space, remember we are doing for the free space, grad is equal to gross H is equal to nothing but the del D by del T. What is this? This is the del D by del T. So what we got here? Mu del square D by del T square. What is D? D is nothing but the epsilon into E. So we can write mu epsilon del square E by del T square. We can also write mu into epsilon, and actually this is in the free space, so instead of mu we can write mu naught epsilon naught del square E by del T square. So we can also write like this, grad square E minus mu naught epsilon naught del square E by del T square is equal to 0. We can also write the equation like this. Now what is the mu naught? If we calculate 1 by root of mu naught by epsilon naught is nothing but the C is equal to light, speed of light is equal to speed of light. So we got the equation from the C is equal to speed of light. So what is mu naught epsilon naught? Mu naught epsilon naught is nothing but the 1 by C square. So we can rewrite the equation as the grad square E minus 1 by C square epsilon E by epsilon T square is equal to 0. This is the electromagnetic wave equation in terms of E. Now we can also discuss the electromagnetic wave equation in terms of H. So again we will start from the Maxwell's equation. So what the Maxwell's equation tells for H? Grad dot H is equal to actually J plus del D by del T. But again in the free space J is equal to 0, so grad cross H is equal to del D by del T. Again if we take the grad in the both side, grad cross H is equal to grad cross del D by del T. Grad dot H minus grad into H is equal to grad cross del D by del T. What is this? Again grad dot H is equal to 0. So minus grad square H is equal to grad cross del D by del T. Again I am taking this RHS only. So what we got? Grad cross del by del T into D. We can rewrite it del by del T grad cross D. What is the meaning of grad cross D? Grad cross D is equal to grad cross epsilon naught. I am writing epsilon naught because it is the free space. Epsilon naught into D. Epsilon naught is equals to constant. So we can write del by del T into E. Now we can also write grad cross E. We can write grad cross E. So again from the Maxwell's third equation we got grad naught del by del T. What is the grad cross T? Minus del B by del T. And what is B? Epsilon naught minus del square by del T square. B is equal to mu naught into H. So minus epsilon naught mu naught grad square by grad T square into H. So if we put the value, we got minus grad square H is equal to minus epsilon naught mu naught del square H by del T square. Minus minus will cancel out and we will get grad square H is minus epsilon naught mu naught del square H but del T square is equal to 0. Again, epsilon 0 and mu 0 is nothing but the 1 by c squared. 1 by c squared. Epsilon 0 mu 0 is nothing but the 1 by c squared, or c is equal to speed of light. So we can write grad square H minus epsilon 1 by c square del square H by del T square is equal to 0. So what is this? This is known as the electromagnetic wave equation in term of H. Now we will discuss about the electromagnetic wave equation for the conductor. Actually this is the modified of the previous one. In the previous one we have taken that the grad cross H is equal to J plus del D by del T. But for the free space we are taking J is equal to 0. But in the practical case grad cross H is equal to del D by del T. So what is the case? We can write again what is the grad cross H is equal to mu into B is equal to del D by del T. So we can write grad cross B is equal to mu epsilon del E by del T. Grad cross B is equal to, in the previous section, mu epsilon delta E by delta T plus mu sigma into E. What is the sigma into E? Actually we know what is J. It is not mu, it is B minus mu. So what we got here? Grad cross B is equal to mu del D by del T. Now what we got here? Mu cross H is equal to plus J. Plus J means nothing but the sigma into E. What is sigma? Sigma is the current density. In the unit 2, we have discussed already that the conductor current density J is equal to sigma into E. So we can write grad cross B is equal to mu del D by del T plus mu sigma into E. What is D? D is nothing but the epsilon into E. So grad dot B is nothing but the mu epsilon del D by del T plus mu sigma E. Remember one thing, while we are derivating this equation, we should not take the mu naught and epsilon naught. Why? Because mu naught and epsilon naught is only for the mu naught and epsilon naught is only for the free space. Now we are thinking about one conductor. So what we got here? Grad cross B is equal to mu naught del E by del T is equal to mu sigma into E. Now again, like as before we have got our equation, we are applying grad cross E and grad cross, we are taking the grad in the both side. So that side we will get grad dot grad E minus grad dot grad E, just like the previous session. Grad dot grad E, we are taking the grad both side same. So what we got here? Grad dot E minus grad dot E is equal to minus del B by del T. So this portion is 0 and we got grad square E is equal to grad cross del B by del T. These things we are again applying for the conductor. These things we are again applying for the conductor. So what we got? Minus grad square E now is equal to minus grad del B by del T, and in the case of the grad cross B we already got mu epsilon delta E square by delta T square minus mu sigma delta E by delta T. So what is the grad square E? Grad square E now, grad square E is equal to mu epsilon grad square B is equal to now mu epsilon grad square B by grad square T plus mu sigma delta B by delta T. So this is the electromagnetic. And what is mu sigma? Mu sigma is nothing but the mu r epsilon. What is the meaning of the mu and the sigma? Mu sigma is equal to mu r epsilon r by c square delta square B by delta T square. So already we got the electromagnetic equation for the conductor. Similarly, we can also same proof we will get for the electromagnetic wave equation for the dielectric material also. And in the dielectric material, again, it is similar like what is the change in the dielectric material? In the dielectric material, again, grad cross E is equal to, we got minus del B by del T. Again, if we take the grad cross E is equal to grad cross minus delta B by delta T. So what is this? Grad dot E minus grad into E is equal to grad cross delta B by delta T. So grad square E is equal to delta B by delta T. So what is the for the dielectric? Now it is a dielectric material. So what is delta B by delta T? We can grad cross delta B by delta T. We can write grad cross delta by delta T, but instead of mu, we can write mu into H. So what is the value? Mu, we can write mu delta by delta T. We can write mu delta by delta T grad cross H. And it is mu grad del by del T. Again, this is a dielectric medium. So the conductor current is again 0. Remember, for the free space is also one type of dielectric. So in any dielectric current, the value of the conduction current J is equal to 0. So what is the delta dot H? Del D by del T. But we should take it as the mu, not mu naught, because dielectric has some permeability as well as some permittivity. So we can write mu delta by delta T epsilon E. So mu epsilon del by del T of del square by del T of E. So we can write grad square E minus mu epsilon delta square by delta T square E is equal to 0. And also we can write grad square E mu naught E means mu r epsilon r by c square, because mu naught epsilon naught is again is equal to c square, is equal to grad square by grad square T into E is equal to 0. So this is the wave equation of the electromagnetic wave for the dielectric material. So already we got this 3 dielectric equation. Now we will discuss the another formula which is known as the Ponting vector. This is also one very important concept in terms of the Ponting vector is a very important concept in terms of the electromagnetic field theory. What is Ponting vector? Ponting vector is telling us the P is equal to E cross H. What is the meaning of the P is equal to E cross H? P is equal to E cross H means if there is some vector P, it will depends on the two part. One is called the E. E is the electric field intensity. And one is the H. What is the H? H is the magnetic field intensity. And what is the physical significance of the Poynting vector? Poynting vector tells if there is an volume and the charge, if the charges are coming out from the volume, it will be in the form of energy. It will be in the form of energy, and this is known as the Poynting vector. And Poynting vector is very important in case of the Poynting vector is very important in the case of the electromagnetic wave equation. Now, how to prove the Poynting equation? Poynting equation can be proved using the again Maxwell's equation. In the Maxwell's equation, we got grad cross E is equal to del B by del T. We got grad cross E is equal to minus del B by del T. Now, if we take the if I cross the H both sides, we can write H is equal to H cross minus del B by del T. Again, we know that the grad cross H is equal to, what is grad cross H? Grad cross H is nothing but the J plus del D by del T. So what we have to do here? We are taking the again E cross, because Poynting theorem is about the electromagnetic field. So what is the meaning of electromagnetic field? Electric field will be superimposed on the on the magnetic field. When electric field will be superimposed from the electric field, we will got the electromagnetic field. So we can write grad cross E is equal to, what is the meaning of grad cross E? Grad cross E is nothing but the del B, sorry, I am taking the E both sides. So what we got here? E cross grad cross H is equal to grad cross J plus E cross J plus del D by del T. So we got the equation. Now this is our equation number 1. This is our equation number 2. So if we minus equation number 1 minus equation number 2, we will get H cross grad cross E minus E cross grad cross H. So we are doing the first equation minus second equation, and we got here H minus del B by del T minus E cross J, E cross J minus E cross del D by del T. So we got this equation. Now A cross, now we can write this equation. Now this equation can be written as the grad cross H, E cross H. From the formula of the Stokes theorem, you can write it grad dot E cross H. The formula will be, the second one will be the fixed derivation of the first one minus first one is the fixed derivation of the second one, or curl of the second one. So here the first one must be E and second one must be the H, is equal to, we can write minus, what we can write here, minus E cross J minus H del B by del T plus E del D by del T. We got this equation. So this side can also be written as this line can also be written as the minus E cross J minus, what is the meaning of H? H is equal to again mu B, B is equal to mu H. So we can write mu by grad T, mu H means H square. Similarly, what is D? D is equal to epsilon E. So we can also write it. We can also write it like plus mu, epsilon del D by del T place we can write del E square by del T square, because D is del T, because D is nothing but the, what is D? D is equal to, we are taking epsilon E, and what is H? H is equal to, what is B? B is equal to mu into H. We are using the formula. So mu into H inside. Again we can write it minus E cross J minus mu into H square. In the place of the mu into H square, we can take the mu inside and we can write del by del T. Mu into H is nothing but the B. So BH plus del by del T, again epsilon inside means D into E. So we got the grad dot E dot H. So if we want to take the derivations both side, we are multiplying the dV. This is a volume density. So if we take the volume both side, we can write grad dot E cross H dV is equal to the big equation minus E cross J into dV plus del dot del T VH plus del by del T dE into dB. I am multiplying the dB both sides. Now if we take the integration in the all the three sides, what we will get here? We will get here, what we will get in the equation? In the equation we will get grad dot E cross H dV. If we take the integration, we will use the divergence theorem and we will get here E dot H dl, E cross H dl. And what is the value of the E cross H? E cross H is the Poynting vector. P dot dl is equal to this big equation. So this is the Poynting vector in for the wave equations. So these are some today I have discussed some tough derivations of the electromagnetic theory. The number one is the Poynting theorem, electromagnetic wave equation for the free space, electromagnetic wave equation for the conductor, and fourth one is the electromagnetic wave equation for the electric of the dielectric. So these four are the very, very important for the time varying field.
Like, share and subscribe. Hit the bell icon for more updates.